Hello and welcome to today's sample class in which we're going to be going over Algebra 2 concepts of systems of nonlinear equations. Today we're going to be going over systems using graphs and systems using equations. Let's go ahead and get started. My name is Mohammad and we're going to be solving problems. First, we're going to look at the first problem in which we're given two quadratics, two parabolas, right? Now, first, we're told to solve for the system. What is a system? A system is where when we're given these two parabolas, which represent equations, the system is where the x and the y value are the exact same for both equations, right? So for example, over here, I have this point which gives me x, which represents x being 1, and this represents x being 1 as well, right? The x value is 1 for both cases. But what is our outcome? What is the y value? The y value in this equation is 3, while for the other equation it's 5. So the y value does not remain the same, therefore telling us that this is not a system. Now, what do we see on this graph that tells us that it's not a system? As soon as I saw the graph, I was able to determine, well, this is not a system. The way how we're able to determine that this is not a system is by seeing that these points do not meet. So essentially on a graph, a system is the points that a quadratic or that any kind of equations line meets, right? When we have two equations. So when given this graph, how can we tell what the system is? The system, in the way how we can tell what the system is by seeing where both equations or both lines meet. In this case, that's this point over here, and that's this point over here. So we're going to take a look at the blue dot first, the blue system first. We want to write the x comma y format, right? We want to write out what is our point. So the first solution to our system is, what's the x value? That is -2. And what is our y value? That's 2, right? We can see that over here. So that is my first point, right? I have -2, comma 2. Now we're going to look at my red point, my red solution. This is the other area where both my equations meet. And the point for this is 0, comma 3, 4, 5, 6, 0, comma 6. There we go. So I now have my system. Now, we always want to check and see, okay, will my two quadratics ever meet again, right? Will they ever meet again? We can use end behavior to determine this. So I can draw out a bit of the quadratic, and look, the quadratics will never ever meet again, right? Because this quadratic over here is, well, it's going upwards, and this one is going downwards, which basically means that they're never ever going to meet again, right? One is going towards positive infinity in our y. The other is going to negative infinity in our y. So yeah, they're never going to meet again, therefore giving us our very first system. So we've solved. We put it into curly bracket notation for correct notation. Okay, we're going to look at question number 2. Once again, a system is where two equations, or two of the quadratics in this case, meet, right? So we have both of these quadratics. Where do they meet? Over here, at the vertex. So they meet at the vertex. Okay, what is the point of this vertex, right? What is the coordinate? The coordinate is 1, comma 2. Do they meet at all after this? Well, let's take a look. Let's look at end behavior once again. This quadratic goes towards negative infinity, right? Its end behavior is as x approaches positive infinity, as x approaches negative infinity, the y will always approach negative infinity, right? While my other quadratic here, this quadratic, as x approaches positive infinity and as x approaches negative infinity, y will always approach positive infinity, therefore telling me that they will never ever meet again. Let's look at number 3. As soon as we look at this graph, what do we notice? We notice that these quadratics never ever intersect, right? They never ever share the same points. So for example, when x is equal to 1 in this equation, in this graph, and when x is equal to 1 in this graph, the y value is different, right? They're different y values. And that's the case for every single point. We can use end behavior to prove this too, to prove that it's never going to meet after this. As x approaches positive infinity or negative infinity, as x approaches positive infinity and negative infinity, the y will always approach positive infinity, right? So y will always approach positive infinity. And in this case, as x approaches negative infinity or positive infinity, my y will always approach negative infinity. Basically telling me that these will never ever meet. So to represent that, I put my curly brackets with nothing in to show that I can't solve because there's nothing to solve for. Okay, now we're going to go away from graphs and we're going to look at the equations. So we were looking at graphs which represent equations, right? They represent quadratics. Now we're looking at the actual equations. Now, they don't necessarily have to be quadratics. So in this case, in question number 4, we're posed with a quadratic, and then we're also given a linear equation, right? So in this case, our system would be like this, or it could be like this, or it could be like this, right? It could be like any of these with a quadratic and with a linear equation. So a system is where y and x value equals same. So in this case, we're given y, we're given x. We're given y, we're given x. Y is equal to y in both cases. So basically, this is equal to this. This is equal to y. This is equal to y, right? So I'm given y here, I'm given y here. They're both equal to the exact same thing. I'm given x here and I'm given x here, right? My x value remains the same in both of these equations, given that I'm solving for a system, as we're given here with this bracket. Okay, why does this matter? Well, because I know that y is equal to the same thing in both equations and x, when I'm given y is equal to blah and when I'm given y is equal to blah, that means that x minus 4 is equal to x squared minus 4x, right? Because y is equal to y. If this is equal to y, and if this is equal to y, that means x minus 4 is equal to x squared minus 4x. Okay? Now what do? Now we can combine our like terms. What are our like terms in this case? Well, this x and this x. And then we also have an imaginary 0 here. So my 4 and my 0. So I'm trying to make a quadratic equation right now that I can solve for 0 using factoring or completing the square or square roots or the quadratic formula, the quadratic equation. So I combine my like terms. So I can subtract x on both sides. I can add 4. Whatever I do on one side, I have to do on the other side. That's algebra. So 0 is equal to x squared. minus 5x plus 4. We're going to take a look. Can I factor this? I can use basic factoring. And this is Algebra 1 standards, so we are going to breeze through the factoring. So I can have x minus 4, x minus 1. They work out by when I use FOIL, I get x squared first outside, which is minus x minus 4x inside. So first, outside, inside, I did that. Now I have to do my last, which gives me plus 4, which is x squared minus 5x plus 4. There we go. And I get that this is equal to 0. So that means x minus 4 is equal to 0. X minus 1 is equal to 0. So x is equal to 4, and x is also equal to 1. Okay? So I have that. Am I done? No, I've only found my x value. Now I need to find my y value. So this tells me that my quadratic and my linear equation meet twice because I'm given two different x values. Now I just need to find what are the y values. So all I have to do is just plug the x value into one of the equations. What equation would you pick from out of these two equations? The linear one, right? You'd pick this one. Because it makes most sense. You don't have to deal with squaring and all of that. It's the most simple. So we have y is equal to x minus 4. So y is equal to, I'm going to use blue. Y is equal to x minus 4. Now I know x is equal to 4 in this case. So that's y is equal to 4 minus 4, which gives me y is equal to 0. Same thing here. Y is equal to x minus 4. X is equal to 1, so y is equal to 1 minus 4. Y is equal to negative 3. That gives me 2 points. That gives me 4, comma, 0. And that gives me 1, comma, negative 3. There we go. Perfect. It's that simple, right? So if we were to go back to geometry, geometry is the grade level math that's before algebra 2. If we were to go back to geometry, we'd remember all our different postulates, all our different properties, and we'd remember that whenever I have y is equal to something, whenever I have y is equal to something and y is equal to another something, that something is equal to something, right? So that's how we were able to solve for our system. We plugged in x minus 4 is equal to x squared minus 4x. We can do the same thing here. And for both of these, we can rewrite these into y is equal to format. So we can literally turn them into y is equal to mx plus, we can turn this into y is equal to mx plus b format. I can turn this into y is equal to ax squared plus bx plus c format. So in this case, it becomes y is equal to x minus 11. We're breezing through this once again because this is an algebra 1 concept. In typical tutoring sessions, I would make sure to ask, hey, I want to make sure that you understand this. My student would confirm that they do. If they don't understand, I would always go over it. And in this, I would get negative y. I'm going to solve for it just to make sure. Actually, I should subtract the 2 here. I should add the y here. So I should get y is equal to x squared minus 5x minus 2. There we go. Now that I have that, it's the same exact thing that we learned in geometry. X minus 11 is equal to x squared minus 5x minus 2. Combining like terms. Once again, that's an algebra 1 concept. So that's why we're breezing through it right now. We get negative x squared is equal to, negative x squared plus 6x minus 9 is equal to 0. Same thing solving for quadratics. This is also a algebra 1 standard. minus 6x plus 9 is equal to 0 because we divide each side by -1. So I get x minus 3 squared is equal to 0, x is equal to 3, x equal to 3. So basically, I get x is equal to, oh, I put it cubed. I get x is equal to 3 and x is equal to 3 2 times because this turns into x minus 3 times x minus 3. So what that can mean, what that basically means is that it like bounces off. It basically means that we have two solutions, but it's actually one. It dives more in algebra 2 later on. In chapter 4 of this textbook, we'd be able to understand. So according to what the student understands and their level of grasping the understanding, I would make sure to whether or not to explain. It's rather unnecessary in this case, but it's always better to understand what's going on in math than to not, to actually understand processes and all of that. But once again, it always varies on the student. So we are going to end off our lesson over here. So essentially, in my tutoring, I want to make sure that my students are able to ask questions and they're able to go along with my explanations, right? I really like to do hands-on teaching. So unfortunately, because this is a video, I can't ask you questions, you can't ask me questions, I can't ask for you to sub into a problem. What I typically like to do with my students is I like to often turn the math into games. I often like to incorporate hands-on things, right? Because our mind's attention span is it. It's hard to pay attention to so much algebra and geometry and math, that we need to make math more engaging, right? So as a tutor, it's my goal is to make sure that you enjoy the math, right? So this video is probably rather boring. I commend you for sitting down throughout this entire video, but I hope to incorporate hands-on learning throughout our math journey. And once again, my biggest goal as a tutor is to make sure that you understand everything and to make sure that you ask questions. I mean, that's what I'm here for. I'm here to answer your questions. Um, so that is a sample of what my classes would be like. I have a really, really good online platform, screen sharing via Zoom, Google Meet. So it's literally just like a classroom setup, but it's one-on-one, just me and you, and fully online. But it's a good infrastructure. Okay, well, thank you so much for going over systems of nonlinear equations using graphs and equations with me. Thank you so much. I hope you have a great day and I hope you enjoyed our first tutoring lesson. Thanks. This was Math with Mohammad out.